Lesson 12-5, Rational Expressions with Like Denominators. And in this lesson, you learn to add and subtract rational expressions with like denominators. So, why is it important? Because you can use rational expressions to solve problems involving history and geography. And let's take a look at this example in history. At 11:40 p.m. on the night of April 14, 1912, the lookout on the bridge of the Titanic spotted an iceberg directly ahead. Despite their heroic efforts, the crew could not steer clear of the iceberg, and the 300-foot gash was ripped in the side of the ship. The Titanic sank less than 3 hours later, and 1,500 lives were lost. The iceberg that the Titanic hit has been described as enormous. However, many people are surprised to learn that only about 1/8 of an iceberg is visible above the surface of the water. This means that the part of an iceberg that is submerged is about 1 minus 1/8. Okay? And 1 minus 1/8 is equal to 8 over 8, which is equal to 1, which is 8 minus 1 all over 8, or 7 over 8. So this is a basic subtraction of fractions with like denominators. So that is about 7/8, or 87.5% of the iceberg is submerged. This example illustrates that to add or subtract fractions with like denominators, you add or subtract the numerators and then write the sum or the difference over the common denominator. Okay, we learned this way back in 6th grade. So you can use this in the same method to add or subtract rational expressions with like denominators. Okay, so with rational numbers, if you have 1/9 plus 4/9, that's equal to 1 plus 4 all over 9. So you're simply adding the numerator, which gives you 5 over 9. In the same manner, when you're subtracting rational numbers, when you have 6 over 7 minus 2 over 7 is the same as 6 minus 2 all over 7, or 4 over 7. So if we take the same Q and do it with rational numbers, for example, if you have 4 over y plus 7 over y, it'll be the same as 4 plus 7 all over y, or 11 over y. Taking it one step further, if you have now 9 over 5z minus 6 all over 5z, that will be equal to 9 minus 6 all over 5z, or 3 over 5z. Okay, so let's use the same principle to add and subtract rational expressions with like denominators. And let's take a look at example number 1. And if you want to find a over 15m plus 2a all over 15m, okay, so copy the problem down and keep the same denominator, 15m, and simply add a plus 2a. a plus 2a is 3m all over 15m. And then simplify 3 over 15, which is 1 over 5. So you now have a over 5m. Okay? Let's take a look at example number 2. Sometimes the denominators of rational expressions are binomials, as long as each rational expression is a sum or difference. Okay? As long as each rational expression in a sum or difference has exactly the same binomial as its denominator, the process of adding and subtracting is the same. So in example number 2, we want to find 4 over x plus 3 minus 1 over x plus 3. Copy the problem. We know that the denominators are the same, so we simply keep the denominator and simply subtract 1 from 4. So you'll end up with 3 all over x plus 3. Again, you cannot cancel 3 and 3 since those are not factors. Okay? So that's the simplest form of the difference of those two rational expressions. Okay, example 3. Remember that to subtract a polynomial, you add its additive inverse. Okay, so we want to find 2m plus 3 all over m minus 4 minus m minus 2 all over m minus 4. So copy the problem, and then we keep the denominator the same, m minus 4, and we simply subtract 2m plus 3 minus quantity m minus 2. And it is important to put the parentheses, because with the parentheses you are distributing the negative 1 to m, and the negative 1 to negative 2. So you end up with 2m plus 3 plus negative m minus 2, okay, which is actually, uh, this should be plus 2 right here. So when you start distribute the negative m, okay, this becomes plus 2, which will be our next line. So that becomes 2m plus 3 minus 3, sorry, 2m plus 3 minus m plus 2 after you distribute the negative 1. And then you add the like terms together, you end up with m plus 5 all over m minus 4. Okay? Move on to example 4. And example 4, sometimes, right, there you go. Sometimes you must factor in order to simplify a sum or difference of rational expressions. Also, a factor may need to be rewritten as its additive inverse to recognize the common denominator. And let's take a look at example number 4, okay? And then we'll look at example 5. So we have 7k plus 2 all over 4k minus 3 plus 8 minus k all over 3 minus 4k. If you notice, 4k minus 3 is not the same as 3 minus 4k. But if we factor out negative 1 from 3 minus 4k, this is what's going to come out. The denominator 3 minus 4k is the same as the negative quantity, negative 3 plus 4k. If we factor out negative 1 from this expression, okay, which becomes negative quantity, negative 3 plus 4k. And if we use the commutative property for addition, this simply becomes negative 4k minus 3, okay, or the same as this denominator right there. So rewrite the second expression so that the denominator is the same as the first expression. But remember, you need to consider that negative 1 right there, okay? So copy the problem and then get factor out negative 1 from this particular expression. And remember, we consider that negative 1, so the addition becomes subtraction because positive times negative 1 will give you a negative. Okay, now that we have the same denominator, keep the denominator 4k minus 3 and simply subtract negative 8 minus k from, minus 8 minus k from 7k plus 2. So this becomes 7k plus 2 minus the quantity 8 minus k. Again, parentheses, you need to remember to put parentheses because you will be distributing the negative 1 to 8 and negative k. So from there, okay, you simplify now. So you now have here, let me expand this here. So this becomes 7k plus 2 minus 8 plus k all over 4k minus 3. And if you notice, okay, 7, redo that, okay, 7k plus k will give you 8k, and negative positive 2 minus 8 or 2 minus 8 will give you negative 6, and keep the denominator the same. And we factor 8k minus 2, 6. Common factor would be 2. So that would be 2 times 4k minus 3. And if you notice now, you have a common factor. 4k minus 3, 4k minus 3. We simply cancel that one out. You end up with 2. Okay? And that is the sum of those two rational expressions. Okay? And let's take a look at number 5. The secret word for this particular lesson is orange. The secret word is orange. Okay? So find an expression for the perimeter of the rectangle ABCD. Okay, this rectangle right here. We want to find that perimeter where you have the length is this rational expression and this is the width of the rational expression. So following the formula of perimeter equals 2L plus 2W, okay, we now substitute the length and the width, which is 9 r all over 2r plus 6, which is our length right there. And this becomes our width, 5r all over 2r plus 6s. Okay, and then we put them in a fraction where you have a common denominator of 2r plus 6s, and simply multiply 2 times 9r plus 2 times 5r. Simplifying that, you have 18r plus 10r all over 2r plus 6s, and factor out or find the GCF and factor out the greatest monomial factor. Okay, but before that, we add 18r plus 10r becomes 28, and we find that the GCF of the numerator and the denominator would be 2. So simplify that, you now have 14 there and 1 there, you end up with 14r all over r plus 3s. Now we can use the other formula for perimeter to solve this. The other formula for perimeter is equal to 2 times quantity L plus W. And if you use that formula, it's I think easier to solve than this method right here. So you have 2 times the quantity 9r plus 5r all over 2r plus 6s. Okay, keep the denominator and simply add your numerators. You end up with 2 times 14r all over 2r plus 6s. And then again 2 times, let me make this into a bracket, 14r, and then we factor out 2 from the denominator, so you end up with 2 times r plus 3s. And from there you cross cancel, okay, the 2 goes away, and you end up with 14r all over r plus 3s. Okay, so if you notice, it's the same, okay, with a lot fewer steps than the method given in the book. And that is our lesson. Thanks for watching.